So soldering lets you make real life circuits and actually put stuff together and do way more cooler projects than you can on just a breadboard. So it's a really amazing skill in a technical sense as well. Now, I will give lab bucks to the first person that raises their hand and tells me what's wrong with the image here. That hand went up first.
Well, she's holding the on part.
Yes. So we love our
Everyone, safety first, please.
Please do not hold your soldering iron like that. Okay, so why do we solder? Some of you guys have done breadboarding before. Maybe you're an ops or you've done something in the past. So when you breadboard, the breadboard is the thing that's actually making connections between components for you, right? Electrical connections, so you close a circuit and you can have your like current flow through. But if you want to do something more fancy, something more permanent than a circuit board where you can just like yank stuff out, stuff falls out, something that looks neater, we use what's called a PCB, which we'll talk about in a bit. But in order to connect something to the PCB, you can't just leave parts in there, right? Because they fall out. So we use this thing called solder, which is like a little substance that we're gonna melt and basically glue components together. And why don't we use actual glue, you might ask? Well, actual glue would hold the component in place. It doesn't actually make a connection, right? So if there's a little bit of a gap between the component and the thing you're trying to connect it to, and you put glue in, there's still gonna be a gap electrically speaking. So solder will basically short between the two and let current flow as if they were connected all along. Okay, so what's a PCB? All of you have a PCB in front of you. A PCB is a printed circuit board. So as I was talking about breadboards earlier, a PCB is like a fancier version of a breadboard. A breadboard, you gotta kind of make your own circuit and you can do whatever you want. A PCB is like, once you've breadboarded your project, you can design a PCB and then you actually order a PCB and you can get the physical boards that you guys have in your hands. And then instead of putting components into the breadboards, you can connect them in a more permanent way. And so it's just a lot neater. It's a cleaner look. You have more flexibility with what you can make with PCBs. So it's very fun.
All right, next, using the tools. So I'm sure you all have noticed there's a lot of tools in front of you. There's 4 specific ones that we want to talk about today. So we're going to introduce them real quick and show you how to tell you how to use them. First one is the soldering iron. I guess this is the most important. You can't do the workshop without the iron. So the soldering iron, obviously, it has a lot of parts, but this is the actual iron part. This is the part that gets hot. This is the part that you do not want to touch with your hands. It's the part that you melt the solder with. The other stop here in the back of the power switch, you can adjust the temperature of the iron as well. And there's also a kind of holder or stand here that you put the iron on when you're not using it. Next. There you go. Next, the solder. You know, there's not much that needs to be said here. Just you know, just pull it out. It's very bendy. Just like get in there and just like melt it on. You know, make the circuit. Next of all is the clamps. So you know, if you're holding the iron in one hand and you're holding the solder in your other hand and you're holding the board in your other hand, that's not going to work. So you should instead clamp the board down, and so that will free up your other hands to do the actual soldering. And also the board can get really hot when you're soldering. So yeah, it's better to just like not hold it in your hands when you're trying to do anything with it. Finally, the fan. So solder fumes are like not really great to inhale. And like if you are soldering in a not well ventilated area, you can feel pretty high afterwards from the fumes. So definitely turn on the fans for your personal health. You know, be safe while you're soldering. Okay.
All right, so now that you guys have some of the background on what the tools actually do and what soldering is, we will get started on what you're going to be doing. The first thing you should do is turn on the fan. Do we want them to do it right now? Or
No.
Okay.
It'll be really like loud.
That's true. Okay, so you want to remember to turn on the fan. That way you're not breathing in the fumes as you're soldering. Okay, step 2 would be to turn on the soldering iron. You want to do this kind of early because it takes a little bit of time to heat up. So it's fairly simple. First, you have to make sure it's actually plugged in to the wall or to the
table.
Yeah, the table in this case. The connections are underneath the table here, but We should have connected all or most of them anyways. And then there's going to be another connection between the actual like iron and like the little brick here that you'll have to make. Don't do that yet, but know that like if you have everything on and there's no heat, that's why it's not actually connected to the power supply. Okay, and then you want to set your temperature. There should be a dial. Some of them might be like digital. We recommend a number between 500 to 600. Of course, the hotter it is, the faster that your solder is going to burn because you're making contact with the hotter surface. I personally solder with like a higher temperature, like 700. It's a little bit quicker.
What a flex. Dude, this guy just flexing. He doesn't need to follow the guidelines.
Okay, so step 3 would be to clamp the board. There's a few different types of clamps. Some of them look like a clamp or like a vise. And if you go into the lab, you'll notice we have these like funky looking ones with like a bunch of hands that
They
you
look
can
like octopi.
Yeah.
They look like an octopus.
Yeah, and they've got clips, and so those give you a lot more flexibility with how you can position your PCB because you can clip around, move them around. It's very helpful. Okay, and then the next thing you want to do is clean and tin the iron. So basically what this means is you're going to take your solder and you're going to hold the iron in a very safe manner, not like the lady on the stock image from like slide 2. And you're just going to melt a little bit off onto the soldering iron, and then you're going to put it into the brass wool and like clean off any of the extra. And it's going to help the solder flow better. When I was first soldering, I didn't do that, and it would be kind of a pain to actually get solder melted and stick in the right places. So this is like one of those tips that like, if you do it, it's just going to make your life so much easier.
Yeah.
Okay, step 5. You're going to stick your components into the board. So right now we're only doing through-hole components, hence the name through-hole soldering workshop. So does anyone know the difference between through-hole components and SMD components, or can tell me what SMD stands for? Yes. Yes. Okay, perfect. So what's the difference in terms of soldering? Does anyone know or have a guess? Yes.
One of them, the solder goes through the hole, and the other one is just on the surface.
Right. So with through-hole components, you just put them into, there's going to be holes on your PCB, and you just stick the component all the way through. For SMD, they're really, really small pieces, and they're going to actually stick on top of the PCB and solder like directly on top of the surface instead of going through. So those are like a little bit more complicated to solder. So we're just going to be doing through-hole soldering for this workshop. You'll have an SMD soldering workshop in the winter or spring. Okay, so when you put your component into the board, make sure it's oriented the right way. Some components, the polarity matters, which means if you put it in the wrong way, your project's not going to work as expected. So for the sake of this project, we'll explain all of that. You don't have to worry about it too much. And then since when we solder, we're actually going to be using the back of the PCB, you're going to have to bend the legs. And the reason you bend the legs is so when you flip the PCB around, it doesn't just fall flat onto the ground, right? Does that make sense to everyone? Okay. So here's a little animation. I'm gonna prepare the legs so you can get them into the holes where you need them. Beautiful.
Just push it in, yeah.
Okay, yeah, so then you bend the legs outward so they don't fall out, and then you actually solder, which realize it sounds like we're skipping a step because it kind of sounds like when someone asks you to explain a word in a sentence and then you use like the same word to explain the definition of the word, but we'll get to it, I promise.
This step 3, you bend the legs. Obviously, the board is upside down, so you know, this helps it not fall out. And step 4, so the next part is actually soldering. I want to point out that step 5 is the first time you pick up the soldering iron. So if you have the soldering iron in your hands, you better be on step 5, please. 5.4.
Oh, okay, right. Okay. Yeah, so I'll explain a little bit more like what's going on here, so you guys know. It's a little bit grainy, but basically, I recommend. We have the next slide. You should hold the soldering iron in your dominant hand, and then the solder in your non-dominant hand, because you need the coordination for the iron, not so much with the wire. You're just kind of feeding it. And so basically, you're going to put the soldering iron in a place where it can heat up both the component and the spot on the PCB. Okay, does that make sense? So like that little corner between the two. So that way both of them are getting nice and hot. And then when you feed your solder in, it's going to melt, and it's basically just going to be attracted to like the hottest spot that it's near. So it might just go under your soldering iron, but then eventually like gravity will let it fall. And then you'll fill up the little hole, and it's very satisfying when you do it right. And all of you guys are gonna feel that satisfaction today. Okay, and then once you've done, yes.
Oh, is it a problem if we actually like touch the soldering iron to the rest of the PCB?
No. They're decently like heat resistant. You're not gonna break the PCB by touching the soldering iron into it. Also, when we were having the lab tools workshops, like some people were concerned about like feeding the solder in and like whether they'll get burned or not. So the thing with the solder is that it melts at like a relatively low temperature. And so while you're feeding the solder in, like it's gonna melt faster than the heat can travel up to your hand. So if you're worried about being burned, like the thing that's gonna burn you is actually iron in your other hand, not the solder. I wouldn't worry about the solder. Okay, and here's an example. You just feed a little bit. And you let it drip, and then you're done with that component. Okay, and then we have a couple tips here. So if the solder isn't sticking, don't leave the iron on for too long, because like if you touch it, it's not going to make a difference. But if you keep it there for like a while, it might actually be bad for your board. And then you should melt the solder onto the pad and not the iron. So that was the reason that we asked you guys to put the heat like in between into the corner, and you're heating up the pad. And then when you feed your solder in, like don't put it directly onto the iron, right? Because then the solder is just going to go onto the iron, like when we tin the tip in like step 1. So make sure you feed it into the actual like pad.
Oh, okay.
Okay.
I'll just throw me in there, okay? So there's different types of solder joints. You can do a good job or a bad job, okay? So there's some qualities of a good job. You can see right here. It should look like this. There's like a volcano shape, and it looks shiny usually, and the component is usually like flat on the board. It's kind of like sticking out, you know, like flying in the air. And so these are some examples of like bad jobs. Sometimes if the solder, you know, it gets like dull or it looks black, or you know, you have too much solder, or what's called a cold joint. You can have, so a cold joint is where you had melted the solder onto the pin, but it's not actually making a connection. So you think you made a connection, but the circuit doesn't think so. Okay. And finally, if you use too little solder, it's not going to work. You know, sorry. And step 7, after you soldered, if you're not actively soldering, always put the iron back in the stand. You know, like this thing is like between 500 and 700 degrees. Like you don't want to like rolling around on your table. That's pretty bad. You know. Then finally, step 8. Once you poke it into the board, the leg will stick out of the other end, right? So we have some cutters here, and you can just clip the legs, and you'll get something that looks pretty flat and nice and easy to handle.
All right, so step 0, we kind of alluded to this a few times, but like safety first, that's the most important thing here. If you can't get your project working, like that's fine, but like if you make it so your hand isn't working, like that's not fine. So make sure that you unplug like the battery before soldering. You should have your fan on so you're not breathing in fumes. You should wash your hands after you solder because the solder here is leaded. So that means it's not gonna like kill you if you're just like soldering with it, but like don't eat it and like don't solder and then lick your fingers. Just common sense. Wash your hands. We don't want a trace amount of lead either. It's all bad. And then don't hold the soldering iron like a pencil. Just be aware of where your soldering iron is at all times. You don't want to burn yourself with your other hand or burn anything else. If there's plastic in your workspace, you don't want to melt that because those fumes aren't good either. And then please turn off your soldering iron and fan when you're done, especially like, well, okay, this goes for anywhere, but if you're going to come into the lab and solder, like make sure that it's off because there's a chance that no one else will go into that area after you. And then that soldering iron could just be like on all night, which is a hazard and it's just bad. And then lastly, just pay attention to your surroundings. So this means your environment, make sure your environment is clean, but also make sure that you're aware of any people that are around you. So if there's someone soldering next to you or someone sitting right behind you, you don't want to like accidentally burn anyone or like you lose track of where something is and you bump into it and then that's all bad.
If you leave the soldering iron on, the lab police will get you.
That's
And
the
you
lab
don't-
police
and
right
you
there.
you don't want to mess with the lab police, trust me. Okay, so now, that was a lot, and I'm sure you all like got maybe a little bit. But I'm gonna demo soldering for you all, just so you actually, can visualize what you're doing. And yeah, okay, wait, let's see if this works first. Oh, that's me. How good is this? All right. I can hold it. Yeah, sure. Oh, can I borrow it? I need a slant. Okay.
Your phone is like keeps splashing. I don't know what the deal is.
I'm sorry. Actually, you want to send to Brandon, actually?
Yeah, Brennan.
Brandon, can you enter the Zoom meeting?
It'd be kind of difficult. I don't want to pull up.
All right, just go with it.
Okay. Yeah. Never mind.
All
We're
right.
good.
And everyone can see, right?
You're good. Don't worry about it. Everyone can see. I'll try not to block. So
Yeah, you're right. Nice. Okay, wait, what is step one?
you tell me. You can ask people if they know.
All right, guys. So first, step one. If anyone knows, just shout it out. No, safety is step 0. Whoever said that, good try though. All right, step 1, turn on the fan. The fan is your friend. It's your #1 fan, always supports you. Next, you want to turn on the soldering iron. The reason why you do it earlier is because the soldering iron needs like time to heat up. It's like an oven, you gotta like preheat the oven before you put in the cookies. Next of all, clamp the board. So I'm using a fresh board right now, but I'm pretty sure most of you guys have like some stuff already soldered in. So yeah, you're welcome. Next, what is next? Oh yeah. Next, I have my solder here.
Yes.
Point it to the, and I'm going to clean the tip by sticking it into this thing. It's this brass wool here. You guys should all have it. Just like poke it in here for like a few times, and you want to tin the top of the tip. So just like put some solder on. Oh my god, my fingers are shaking. And this is not like. Okay. Unfortunately, yeah. So now there's a little bit of solder on the tip, just like poke it in, and then that will kind of smooth it out a little.
I think it's next.
Yeah, like this. All right, this is quite hot, but it's okay. So now, put this back, and we want to find our component. So the first component is going to be the resistor, right here. And so the first thing you want to do, obviously bend the legs and then stick it right into the board. Like that, so it's completely flush against the board. And now we can flip it over and bend the legs outwards. And now that we're here, we're ready to solder. So the first thing I'm gonna do is I'm gonna take my iron. I'm right-handed, so it's in my right hand, solder's in the left hand. And first thing I wanna do is I wanna get the iron in first, and I'll heat up the pad. And then I'll put the solder in. And then, okay, that was pretty quick, but so I put this iron in, solder in, and it's melting, and I take the solder out, and then I take the iron out. And so then you can see, in close, I don't know if you guys can see clearly, but the joint is soldered. So that's what it should look like. that is like an example of a good joint. That's like kind of what you want to hope for. I'm gonna do the other one right now.
Also, you have a bunch of examples on your board.
Yeah, that is also true. So iron in first, solder, and then it's melting on, solder out, iron out. So I just want to, yeah. So that's what it should look like. Are there any questions here about what just happened? Sorry? Yeah, it cools really quickly. So it cools like basically right after you take the iron off. Yeah. Yeah, so yeah. How do you know? Okay, that will come later.
Yeah.
Okay. Now, okay, now I'm gonna do 2 more components just so you guys can like see what's happening. I'm gonna do an LED now. So the LED is kind of specific. You have to put it in a certain direction. There's a flat side of the LED, and it should face to your right, like this. You should follow the little shape on the board. And if you do it the other way, it'll break. Haha. Yeah, so now I'm clamping it in. I'm bending the wires out. And then I take the soldering iron, put it, okay, and I'm gonna go in. Now, remember, iron in first, then the solder out, and then iron in. Okay, well, then iron out. And so now that the joint is like pretty set, you can take the iron out and you just like let it hang out. It's cool, it's set in place now. And then you can do the other side. So iron in, solder. Like shaking. All right, yes. Iron, remember, iron, solder, solder, iron. Okay, that's the secret. Trust. Okay, for now, I'm gonna do one more. Yeah.
So that's the optimal way of doing it. If you put the solder onto the iron, you could still get it to work, but it's just gonna melt onto the iron, and then you have to like wait for it to drip on. Yeah, so it's a little more work, and then for getting like nice clean joints, it's more consistent to feed it directly onto the pad because you might get too much if you're melting directly onto the iron.
All right, just one more example, and then this one will be more specific, I guess. So I've put the LED in. I'm gonna flip it over. Oh, actually, I have to do this side. Do it from this side. Put it into the board, and I'll flip it over. Make sure you get this one. Now here, I'm gonna reclamp it again, legs out, and I'm going to, again, solder first, then soldering iron first, then the solder out, iron out. In reality, you only need a little bit of solder to make it actual joint. Finally, last thing, so you can see here, I'm gonna go in and try to solder again. I'm holding the solder pretty close to the tip, so, and I'm like not worried at all by it, but you should, so you don't have to really worry about getting burned by the solder, as we said earlier. But one thing that can happen is you accidentally like touch your fingers, right? And so that's gonna hurt a lot because the iron is really, really hot. And if that happens to you, it's gonna hurt. You get
David literally did it for you
get a
guys.
blister.
Yeah.
And if that happens to you, just let us know. Like, you're not dumb, you're not stupid. It happens to everyone. But just remember to like be aware of where your fingers are, and stay safe.
Why did you do that?
We have hand sanitizer, and I have a little bit of coffee for you. Oh, I have Band-Aids too. Yeah. All right. Yeah, so you get a blister.
Yeah. So as you guys can see, David literally touched the soldering iron. Like I'm not even kidding, and you can see the blister on his finger. Don't be like David. In this particular instance, be like David in other instances.
Okay. Now, I'm gonna try to get in here. Okay, but let's say if this happens, let's say this happens, you know, and you get solder in some place that you don't want.
So it's kind of hard to see, but
Yeah.
in this case, he put solder into one of the holes next to the LED, which is where you don't want solder because we're not putting in a component in yet.
Yeah, so, oh no! All right, we're in trouble, guys. I actually don't know how to solve this.
All right. Good thing I know how to solve this.
All right, perfect.
Okay, so solder sucker. So there's a couple more tools that we sort of excluded from the beginning thing when David did his me and the tools bit, because those are where you need to solder. So those are the bare minimums. If you have those, you can solder. But if you make a mistake, that doesn't mean you can necessarily fix it. So if you have too much solder on a component, or you filled up the hole for a component that you haven't put in yet, and you need to get the solder out, one of the things you can do is use a solder sucker. So the lab has this stuff. We're just trusting that you guys won't mess up. I'm kidding. We'll have a couple for you in case you do mess up. But so you basically heat up the solder, right? You make it into a liquid again. If you use the solder sucker and you haven't heated up the solder, it's just like a cold piece of metal, and it's not just going to go into like a syringe looking thing. So then you press down on the plunger until you hear it click. And then once the solder is actually melted, you put the tip of the soldering pump against the solder that you want to remove, and then you release the plunger, and then it should pull the solder out once it's in a liquid form. So again, the main thing is like make sure that it's hot enough. If you're just sitting there and like clicking the solder sucker and it's not doing anything, it's probably because you haven't melted the solder. Okay, I personally don't like to use the solder sucker that much. I find that the solder wick is a little more like it's a little quicker and easier, and it gets the job done. You can use either. There's no requirement. The solder wick is basically like a bunch of copper, and it heats up pretty fast. And so what you want to do is you want to basically put it like in between the solder that you're trying to remove and the iron. And the idea is that it gets really, really hot, and so the solder will stick onto the wick and then basically come off of the joint, because the joint is like a lower temperature. Does that make sense? So here's some more specific instructions, and then we have a little chip. Okay, so okay, so let's talk about the project. This was advertised to you guys ahead of time, so it shouldn't be a surprise that your project is going to be an IEEE sign. The intention is for you guys to put in all the components. We've done the I and the E for you to make it a little bit easier so it doesn't take as long. And the idea is when it's fully complete, what you should be able to do is either snap or clap and it will turn on. There's a little dial here that if you turn with like a screwdriver, you can change the mode. So it's blinking right now. You could set it to just always be on or blink at a slower speed. So it should be very cool. We want everyone to finish today. It's okay if you don't finish today. You can come into the lab whenever you're free between the hours of 10 a.m. to 6 p.m. Monday through Friday. And there's soldering irons there you can come in and use. If you need help, there's always officers in there. So for right now, let's get started because we did start a little bit late. Yeah. So do not turn on your soldering irons yet. We're gonna pass out some stuff. Okay. You can turn them on. If you turn them on, like please be very aware that your soldering iron is on and don't pick it up like it's not. And then we're going to talk more about the individual components that you're soldering. Okay. At some point, I walked around and gave people like 2 transistors. Did anyone not get those 2? You didn't get 2? All right.
Wait, David, are you guys done with this?
Oh, he just made a
That
clap.
one
Oh,
was
sorry.
theirs, yeah, sorry.
Oh,
Solder. We're gonna get more. But if you want, you can just, like take a bunch and like break it and use that. Okay. Yeah. All right, everyone. Everyone, we have sent reinforcements to the lab to get more solder and stuff. But for now, we're gonna talk a little bit about what's happening, because there are several ways you can actually screw up PCB, and that would be very sad because we worked very hard on soldering all the LEDs in. Right in, Brennan. Yeah. All right, you know what? These are the steps.
okay. Okay, so real quick, here are some things that you can do incorrectly that will make your life a little bit more difficult. If you solder in all the LEDs in backwards and you wait till the end and you, do you have the example board? So, okay, so say you solder in all the LEDs, you finish your whole thing, but all the LEDs are backwards. What you're gonna have is something that took a lot of time and effort and part of your soul, and you were gonna plug in a battery and it just won't work. And the way to fix it is to desolder every single LED and pull it out. So please solder them in right the first way. It's also helpful if you don't clip the legs until like you're sure that you soldered in right, because once you clip the legs, it's gonna be infinitely more difficult to actually remove it and put it back in the other way. So that's something. And then there's some more tips here regarding polarity. So make sure you put in the parts the right way. If you have questions, you can ask us. And then the resistor values are on here, but the resistors are like also not labeled. So we will help you clarify. But you could start with the 330 ohm resistors, because everyone should have gotten those in like a little packet of 3. So if you see 3 resistors connected to each other, those are the 330s. You can start on those.
Okay. All right.